Okay, good morning. How are you, everybody? All good? How was the weekend? Yeah, yeah, perfect. Yeah, for that reason, I prefer always for the math lesson to be after the weekend, especially if we are having a very important topic. Okay, all good. So last lesson, if you remember, we discussed the quadratic equation. Okay, Mark, what the shape of each curve is called? Good. So it's called the parabolic function or equation. Do you have something to add? Yes, Amy. Very good. So it has two roots, as we said. Something else, Yasmin? Yeah, we can solve by graph. Can you tell me the shape, Mark? Very good. So here are the axes. Yeah, like this, and cutting the x-axis in 2 points. These are the solution of the parabolic function. Good. Ahmed? Yeah? Do you need to add something else? Perfect. So the factorization method, okay? Very good. Yeah, and the scissor x, yeah, constant k1, k2, plus or minus, plus or minus. Perfect, Adam. Perfect. All good. So this was the quadratic function. And last time we stopped when we said that sometimes we cannot factorize the quadratic equation to its real roots or to its roots. Let us now put real and imaginary aside. It's something outside our scope. So it is very hard to make the factorization to x or something x, 2x, 1x, whatever, plus a constant times another x multiplied by constant plus or minus another constant, which is this form. Sometimes it is hard. We cannot factorize it like this. So in this case, what do we do? First of all, I need you to concentrate with me because we need to revise some things about the function and about the geometrical shapes, and then we'll start our exercises in our groups. Okay? So if I'm saying that 3 plus 2 equals 5, 3 plus 2 equals 5. If I need to change something in this side from the equal, this is called the left-hand side, and this is called the right-hand side. So if I need to subtract 1 here, shall I say 3 plus 2 minus 1 still equal to 5? What do you say, Steve? No, so I must do the same here. So whatever I do in the left-hand side, I must do the same in the right-hand side. Okay? And also, if I need to apply something to the whole equation, I'll apply it to both sides. So, for example, if I need to divide by 7, this means I need to make 3 plus 2 divided by 7 equals 5 divided by 7. Okay? If I need to take the square root, both sides, so I say square root of 3 plus 2 as a whole, the left-hand side, equals square root of 5. Okay? So whatever I do in the left-hand side, I must do in the right-hand side, so that the equation is still valid and both sides are really equal. Okay? And I think this is logic. Let us now revise also some basic concepts about the shapes and the areas, because we'll be using this in our lesson today. So what about the square. Let us revise together. The square has a side. All sides are equal. Let us say that this side is called x. So this side must be equal to x. So this area is x. Huh? Muhammad? Perfect. X squared. So side times side. We are talking about this area. The x squared. Okay, so this is the square. When both sides are equal. Okay? Let me give another example. Let me give another example about the rectangle. So the rectangle will have two sides, but they are not equal. So let us assume that one of them is y and the other is x. Whatever. Sama, can you tell me the area, please? Perfect. So area equal x times y. This is the whole area. So now we revise this. I need you into your groups. And you remember last time we defined how our group must be working, and we shall appoint the leader, and we shall distribute the tasks, and we shall do all the functions that we did even within our group and within the time limit that will be given to you. So within your groups, you have now the coloring sheets that you took at the beginning of the lesson, and you have also the coloring pens, and you have the scissors. So everyone in the group and each group has a specific shapes or areas that need to be cut using the scissors and the coloring sheet, so that I'm sure that you understand how to transfer the symbols in an equation into areas inside the coloring sheets or cut from the coloring sheet. Okay, so I'll give you an example. So the first group, Hassan, you are in the first group. The first group will have an equation called 2x squared plus 3x equals 7, or minus 7 equals 0. Okay, so I need you to make from the coloring sheet something called, the area is 2x squared, and another shape, the area is 3x, and another shape, the area is 7. 7, whatever the unit is, centimeter square or whatever. Okay, go ahead. You have the scissors, you have the coloring sheets, and distribute the tasks. So one do this term, the other one does the second term, and so on. Okay, let's go. Very good. No struggle, no struggle. Yeah, you have limited time. You need to finish. Show me. Ah, perfect, perfect. Very good shape. Okay, thank you all. So this was how to transfer the terms of the equation into graphical shapes. So as you have seen, we need to simplify the equation so that we can transfer it to geometrical shapes. So let us take an example and say that this equation, x squared plus x or plus, let us say, sorry, x squared plus 2x plus, so no, I'll give another example. I just need it to be an easy example. So forgive me. 3 and 4, 12, 1. equals 0. Okay, this is a function. Okay, we need to discuss now something called completing the squares. So I draw x squared as a square with two sides. Each one is x. Okay, I'll move this 12 here, so the equation will be x squared plus x equals 12. I need to draw this x as also a shape with area x. So I can say x times 1. So this is x, the same as this size, and this is 1. Okay, so this is x, and this is 1. Okay, equals 12. It doesn't matter the size of the 12, 4 times 3, 12 times 1, it doesn't matter for me. So now I need to make something called completing the squares. I'll divide this rectangle into two equal rectangles. So this one will be half, and this one will be half as well. Then I'll move each rectangle to a side of the square. So x will be like this, with this added rectangle here, and another one added here. So this one is half times x, and this one is half, and this of course is still x, and this is x. So half times x, half times x, I've added them to this shape. Is this shape a square? Nah, so this part must be added so that the whole shape is a square. Let me add, so this is x squared plus x. I need to add this term. So if I added it here, I must add it to 12 as well, so that the equation is still valid. This square is half, as you can see, and this is also half. So half squared. So I can say x squared plus x plus half squared equals 12 plus half squared. Okay? And now, what is the area of this whole shape? It is x plus half. This is the half, and this is the x. Okay? Times x plus half. So this is x plus half squared equals 12 plus quarter. And from here, I can straight away get the value of x easy by taking the square root of both sides and then transferring the half to the other side, and it is easy. Let me generalize this concept. So if you can see here, the x had a coefficient of 1, and then we took half of that coefficient to make this rectangle and to add it to that square. So let us generalize this equation to derive the quadratic formula that we need to derive today for the equations which are hard to factorize. So ax squared plus bx plus c equals 0. This is the general form of the quadratic function, okay? This is the general form of the quadratic function. So first of all, I need to complete the square. So I'll transfer this c here. So it will be ax squared plus bx equal minus c. Then I will divide the whole equation by a to leave the x squared by itself. So x squared plus b over ax equal negative c over a. Then I will draw the squares normally. So this is x and x squared, and this is here x again b over a. Okay, I add them, and here there is something called negative c over a. Okay, so now I'll take half of this, so b over 2a and b over 2a, and add them here. So it will be like this. I need to remove this. So it will be x, and then b over 2ax, and here the same. This is b over 2a, and this is b over 2a. Okay, and I need to add this square to make it a complete square. Okay, this is b over 2a all square. So as if the function is x plus b over 2a, x plus b over 2a all square equals negative c over a, and I added here plus b square over 4 square, so plus b square over 4a square. Okay, from here we need to continue to derive the rest of the equation. Okay, are you with me, Mark? All good? Yeah. So here, x plus b over 2a squared equal negative c over a plus b squared over 4a squared. If I need to add both of them, so I need to multiply here by 4a and multiply here by 4a. So this will be negative 4ac over 4a squared, and this plus b squared over 4a squared, which is equal to b squared minus 4ac all over 4a squared. And all of this is x plus b over 2a all squared. Okay? So let us now continue from here. Let us now continue from here. So if I take the square root of both sides, it will be x plus b over 2a equal, all of these are constant, so I need to put the plus or minus as we explained before, square root of b squared minus 4ac over 4a squared. Okay, this is equal to plus or minus square root of b squared minus 4ac over 2a, the square root of 4a squared, and we already put the plus or minus here. So if I transfer this here, it will give me x equal negative b over 2a. Yeah, this is correct. Plus or minus square root of b squared minus 4ac over 2a. The same denominator, so we can write it again in this form. So here is it. So x equal negative b, positive or negative square root of b squared minus 4ac all over 2a. So these are the two values of x. Negative b plus square root of b squared over 2a, and negative b minus the square root of b squared, and so on. So completing the squares enabled us to get or derive the general formula for solution of quadratic functions when the factorization is very hard. Okay, so now you have your assignment books in front of you. Kindly open them. Yeah? Okay? Everyone has a function. Kindly apply. Where is the A? Where is the B? Where is the C? Yeah? Someone will apply the formula? Perfect. Huda. Yeah. Okay, I'm waiting for you. Yeah? Awesome, awesome. I can see that you did a good job. And now, what did we learn this lesson? First of all, completing the squares. Second of all, yeah, Mark? Yeah, equating both sides of the equation. Third of all, Yasmin? Yeah, the relation between the geometrical shape and how to transfer the equation into geometrical shapes. Yeah, and finally, the formula x equal negative b plus or minus b squared minus 4ac over 2a. And now you can remember from our last incursion when we shoot some balls with our hands, the trajectory or the path that it moved so was drawing the parabolic function or the quadratic function. Next lesson we'll be discussing practical application for the quadratic functions, and we'll be applying the formula to solve more and more examples and to see the different cases that we can get the quadratic function with. Thank you for listening and have a nice day, and see you next lesson.